This lesson will look at solving right triangles with trig, part 2, finding a missing angle. First, we need to start by taking some notes about the calculator. You have to make sure that your calculator is in degree mode. It's a necessity. You also need to find the missing angles. Or to find missing angles, you must hit the second buttons before you hit the sine, cosine, or tangent buttons. That'll get us this little sine to the -1, which means inverse sine, or cosine to the -1, which means the inverse of cosine, or tangent to the -1, what gives us the inverse of tangent. So let me show you that on your calculator real quick. On your calculator, sorry, I'm having a little technical difficulties. On your calculator, you're going to go to the mode button, scroll down to where it says degree, make sure it's highlighted and hit enter, and then you can scroll up. We're going to do a float of 4 today. Remember, that only gives me 4 decimal places. And get back out of that. And today what we're doing is we're trying to find an angle that might be missing in our trig, with our trig functions in a triangle. So what we're going to do is we're going to hit the second button and then hit sine, so we get that inverse. That's what it'll look like. Or we can hit second cosine and get the cosine inverse. Or we can hit second tangent and get the tangent inverse. So let's go ahead and look at an example. Example 1 says find the missing angle or angles. We're going to do this very similar to what we did on the previous lesson. We're going to find the angle that's missing. I'm going to start by marking it, and that would be x. Then I'm going to label my sides. I have the hypotenuse, and I have the opposite. Remember, the opposite side is always across from the angle. So if I write my trig reference table again, like I did in the previous lesson, I have sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Remember, from a couple of lessons ago, I stated that this, we were told, or I was taught when I was younger, Oscar has a heap of apples. Sorry for the lightsaber there, that was kind of weird. I don't know where that came from. So, anywho, we have the opposite, which is right here, and we have the hypotenuse. So we have O and we have H. That is our sine trig ratio. So we have the sine of our angle, which here is x degrees, is equal to our opposite, which is 9, over our hypotenuse, which is 16. Now, we need to find what x is. And to be able to do that, we'd have to take the inverse of sine, and what you do to one side of your equation, you do to the other. So we would take the inverse of sine of 9 over 16. That cancels here, you got it over here. So when you have all this mess, the easiest way to do it, what we can write our equation, is the inverse of sine of 9 over 16. And that is what we put into our calculator. Let me show you what it looks like on the calculator. So on my calculator, I just said our equation is the inverse of sine, so I hit second sine. Then I have my opposite, which is 9, divided by my hypotenuse, which is 16. So my angle there is 34.2289 degrees. So the angle that's missing, or my x value, is 34.2289 degrees. And that's it. Let's look at another example. Find the missing angle. Again, we'll start by marking our angle, which is x. 54 is our hypotenuse, 27 is our opposite. So again, we're using sine. Remember, we're looking for an angle, and this is the only time that we'll use the second button with our trig functions. But we know the inverse of sine is equal to my opposite, which is 27, over my hypotenuse, which is 54. When you plug that into a calculator, you're going to hit second sine 27 divided by 54. And that's 30 degrees. Now you may be asking yourself the question, where did she get the sine? How did she know to use the sine trig ratio? Again, remember that little reference table that I always draw. Oscar has a heap of apples. I recognized that I had my opposite side and my hypotenuse, so I knew right off the bat that I was going to use my sine function. Let's look at the table. Here we have two missing angles. Let's start by finding x. I'm going to ignore the fact that there's even a y. So I'm going to mark my angle, which is x. Based on x, 8 is my opposite, and 13 is my hypotenuse. So, again, draw that little reference table out. I have my opposite and I have my hypotenuse, so I'm going to use sine, and we're looking for an angle, so I'm just going to skip to finding my inverse. The inverse of sine of my opposite over my hypotenuse. If I plug that into the calculator, which I'm not going to show you, I'm just going to go ahead and do it. That gives me 37.9799 degrees. Now let's find our y. Remember, when I do this, when I find my y, that the hypotenuse will always stay the same, but now my side that is 8 becomes my adjacent, not my opposite, because it is now helping to form the angle. So I have my adjacent and I have my hypotenuse. That is cosine. So I know I'm using the inverse of cosine because I'm looking for the angle measure. So in the calculator, you'll hit second cosine to get the inverse of cosine. And then I have my adjacent, which is 8, over my hypotenuse, which is 13. When I plug that in the calculator, I get 52.0201. If you ever question if you might have done it right or wrong, you can add the two angles together, especially when you have two angles that are missing. You can add them together and they'll add up to 90 degrees. Now let's look at it part D. So let's look at example D. I'm going to start by giving you the trig table, or the trig reference table as I like to call it. And we'll start by finding angle x. Based on angle x, 18 is our hypotenuse and 11 is our adjacent. So I know I'm using cosine because that is my trig ratio. Cosine is the adjacent and the hypotenuse, over the hypotenuse. So I have the inverse of cosine, because I'm looking for the angle measure, is equal to my adjacent, which is 11, over my hypotenuse, which is 18. In the calculator, I will type second cosine 11 divided by 18, and that gives me 52.3301 degrees. And now for my angle y, mark my angle. Again, hypotenuse doesn't change, but now this side becomes my opposite. So I have my opposite, I have my hypotenuse. That will give us our sine, opposite over hypotenuse. So I need the inverse of sine of my opposite over my hypotenuse, so 11 over 18. And that is 37.6699. That's all there is to finding a missing angle in a right triangle when we're using trig. If you have any questions, please let me know. You can always send me an email.